One of the things I find most exciting is when a topic that you thought was sort of squarely confined to your field turns out to have a completely different interpretation and meaning in another field, maybe another field of math, or maybe in physics, or chemistry, or biology. I mean, it's almost like a mystery, and you're the detective, and you have to sort of follow these clues to try to figure out what's going on. My name is Lauren Williams. I am the Dwight Parker Robinson Professor of Mathematics at Harvard, and my research area is in algebraic combinatorics. I started studying a geometric object called the positive Grassmannian. I was studying it purely because of its mathematical beauty. A mathematician named Sylvie Courtil wrote a paper explaining that the polynomials I wrote down to count cells of the positive Grassmannian actually were also computing probabilities in a model called the asymmetric simple exclusion process, which is a model developed by biologists to study translation in protein synthesis. This is also a model that's been used to model traffic flow on a one-way street. My polynomials had these completely different interpretations, and I got, of course, very intrigued. And then it led me to study soliton solutions of the KP equation, these solitary waves that maintain their shape and velocity. In the last 10 years, it's led me to study an object from physics called the amplituhedron, related to high-energy physics, and in particular, probabilities describing what happens when a bunch of particles with given momenta collide and interact. Together with some colleagues, we are starting to develop a framework for testing AI's capabilities at doing math research. There's a group of roughly 10 of us in different fields of mathematics, and we are taking math problems from our own research that we have recently solved. These are all problems where we can ask AI to try to solve them, and AI won't just be able to look up the solution somewhere on the internet. And so this is a kind of a first attempt to come up with a reasonably objective test of AI's capability of doing research-level math.